Hi, today I'm going to present a paper called 3DSA Multi-View 3D Human Pose Estimation with 3D Space Attention Mechanism. So the contribution of this paper are they propose the 3D space attention module, which address the drawback of the existing result-based multi-view 3D pose estimation method. And they introduced the 3D space subdivision algorithm to reduce the computational complexity of the module. And by integrating their 3D space attention module into the existing result-based multi-view 3D pose estimation method, they achieve a good result on the panoptic benchmark. So the multi-view 3D human pose estimation, they leverage image from multiple camera point of view, and they estimate the 3D pose of the humans. So instead of relying on a single image, multi-view method, they aggregate the information from multiple perspectives to overcome the ambiguity or occlusions. So the voxel-based method, they discretize the 3D space into a grid of voxels and predict the joint location within this voxel grid. And this method, they can avoid the incorrect decisions in each camera by directly operates in the 3D space. So the first method that introduced the voxel-based multi-view 3D human pose estimation is voxel pose. So the key ideas of this paper that they divide the 3D space into a voxel grid, and they predict the probability of each voxel that being occupied by a human joint. So instead of performing explicitly 2D to 3D mapping, they learn end-to-end mapping from the multi-view to the image into the 3D human pose. So if you look to the top line, so they take a multi-view image as the input, and then through their CNN background, they first estimate the heat maps, the 2D heat map, then they project it into a 3D voxel, and then they try to get the proposal of the 3D human pose. And through the 3D CNN, they can get the 3D pose of the humans. So for the existing 3D human pose from multiple camera view, they are complex because of the variety of the visible caused by different point of view. So the traditional voxel-based multi-view 3D pose estimation, they primarily project the heat maps into the 3D space. Here, they project it into the 3D space without adjusting for the visibility difference, which means that they neglect the importance of the different region that might be more crucial for the accurate pose estimation. So to address this problem, in this work, they introduced a 3D space attention mechanism that allows the model to focus on a region in the feature volume based on their visibility. By adjusting the feature volume with the weight attention score, the method aims to enhance the discriminative learning and improve the accuracy of the 3D pose estimation. So if you see the image here, we have different point of view. We have view 1, view 2, view 3, and view 4, and view 5. So So the visible of the view can be very depend on the point of view. As you can see here, this people in view 1 to view 4, we can see him clearly, but when we rotate or when we move to the view 5, this person become obstruction, which means that we cannot see his visibility. So in this work, they propose the space attention module to address this problem, to enhance the feature volume by preserving the 3D information and also emphasize the crucial region inside the feature volume. As the objective to focus on the region within the feature volume by apply the attention weight. So this is the overall outline of the proposed method. They have 3 components. The first one is the heat map and space attention prediction here. So they take the multi-view RGB image as the input, and then through their background, they predict the heat map and space attention score. For its heat map, it is projected into a 3D space, and the attention score of the H view is assigned to different regions to assess 3D space attention. And for the space attention with the Pearson proposal generation component, they performing the element-wise multiplication of the feature volume with the 3D attention score to produce a feature volume by infuse the attention score with the feature volume, and then through the 3D convolutional neural network, they can locate the per person proposal. And the last component is the space attention with per person region. So they try to create the more detailed feature volume corresponding to the proposal. So by calculation, the spatial relationship between the proposal with the feature volume and the attention score of the proposal, they can create a more detailed feature volume that corresponding to the person proposal. Finally, they can estimate the 3D human host. So if we look clearly into its component, the first component, they just adopted a multi-layer design with a backbone and 2 additional layers. One is the heat map layer, which predict the probability of a 2D post heat map for corresponding view. And the other one is the space attention layer, which predict the attention score of the feature volume. And this attention score are just based on the input image to emphasize their regions with the higher visibility in the 3D space. And the other component is the space attention with Pearson proposal generation. So they project the 2D heat maps by the previous component into a 3D space, and they discretize the feature volume into the X, Y, and Z location. So by directly projecting the importance of it also in the feature volume, they could produce a very overwhelming computational burden. So by having a feature volume of 80 by 80 by 20, it could produce the overall computational of 122,000, so which very high. So they're trying to reduce the computational complexity by introduce a 3D space subdivision algorithm to divide the feature volume into several regions. And then they apply the space attendance score, which predicted by the backbound, uh, to each region in the divided feature volume to compute the attention of the feature volume. And the space attendance score predicted by the model are assigned to each region in the divided feature volume to compute the attention of the feature volume. After that, they do the element-wise multiplication between the space 3D space attention and the feature volume to obtain a feature volume with attention space. And the last component is space attention with a per person post regression. So in the final step, the fine-grained feature volume center around each person are created. So they sample the attention score of each proposal by analyzing the spatial relationship between a proposal and the feature value. Then they employ a nearest neighbor sampling method to precisely calculate the attention score of each proposal. So they aggregate the fine-grained feature is computed based on the selected region and the computed attention score. And a 3D heat map from this aggregated feature volume is estimated to capture the predicted 3D joint locations of the individual. And then the complete 3D human pose are then readjusted based on the heat map. So as I said earlier, so instead of directly apply the 3D attention space attention into the feature volume, they divide it to subdivision for reducing the computational complexity. So it divides the feature volume into distinct regions, and then the voxel in region are considered as a group, and the attention score are assigned to each group to not take the importance of each region. And then through the backbound, they get the weight attention of each region to provide the importance of the responding area within the same point of view in the feature view. And if the voxel within a specific region provide higher confidence levels, it indicates that they are relative important. Otherwise, with the lower confidence levels in the voxel, which may be caused by the occlusion, suggests that they are less important in the region. So this is their 3D space attention module. It is a simple convolutional block to estimate the 3D space attention score of its corresponding image. So it is live design and that use a simple convolutional block followed by the global average pooling and a sigmoid function to estimate the space attention score for the corresponding image. So for the experiment, they evaluate their performance on the panoptic, compose, and the soft data set. And for the panoptic data set, they use the AP and PJPE as the evaluation metric, and for their compass and the soft data set, they use a percentage of correct part as the evaluation metrics. And for the training, for the backbone to estimate the 2D heat maps, they employ a resonant 50. So this the 3D attention visualization. As in picture 5, the human body is obstructed, which is not a visible from the viewfinder angle. So we can see that the result in lower attention score, which is the blue area, which means that it is less important. And it's confirmed that the space attention mechanism can discriminate the importance of the different region in feature volume based on the visibility. They did the evaluation on the panoptic data set, and by incorporating the 3D space attention score into the existing workflow-based method, they can increase the good result on AP50 evaluation metric. So for the voxel pulse, uh, it achieved a 54.2%, and for the faster voxel pulse with the 3D space attention mechanism, they achieved 94.22%. And this is the effectiveness of the attention space module by using different input. They have a image as the input and the heat maps as the input. So by incorporating the 3D space attention between image as the input and the heat maps as the input, they could perform well. So the for the image as the input, they achieve 94.2 on AP25. And for the heat maps as the input, they even achieve better performance on AP25. And also for MPJPE, if they use the image as the input, they can achieve 13.95. But when they use the heat maps as the input, they achieve MPJPE by 17.20. And they also report the quantitative evaluation results on the set and the composite data set. For these two data set, they could not outperform much than existing method, but they still remain a competitive result on both data set. As you can see here, they could not outperform the existing method, but the results still remain the same. So in conclusion, in this paper, they present a novel space attention module for voxel-based multi-view 3D post-estimation method, and then they learn the space attention score from the input image and utilize the 3D space subdivision for a computational burden, and finally they construct the feature value with the 3D space attention. So by integrating the space module into existing voxel-based method, they achieve the state-of-the-art result on the panoptic benchmark. So, thank you so much.